Welcome back, everyone. Today we're going to remove the flywheel. Now, I don't have an impact gun. My father does, but I'm not driving all the way to where my parents live right now. It's late and I don't want to go anywhere. This is going to be what I call a lesson learned, hopefully not a lesson learned opportunity. This is going to be something that I've never done this way. But it's a widely accepted method of removing a flywheel nut in the scooter community. And I'm hoping this works. I really hope this works. And I don't ruin anything, such as the crankshaft or the connecting rod. So how am I going to do this? Well, I've already removed the jug and the head and the piston and all that happy stuff. And I'm going to take this T-handle and I'm going to stick it through the connecting rod. And I'm going to back the connecting rod up against the block like that, and then we're going to use this heavy duty, actually I'm going to use a breaker bar, and I'm going to loosen that flywheel nut. I've worked in a lot of engines and I know they're not that fragile, but I've never done this. I've always used an impact, but I don't have one right now. So to protect the deck surface of the block, I'm going to put this rag between the T-handle and the block. It's something that I just came up with, and I feel better that way. That way, it's got a nice soft surface rather than going straight against that alloy block. I'm going to try it first with this ratchet and see if it's really that tight. Here we go. Oh, you know what? I was worried over absolutely nothing. Yeah, here's an example of where I actually have the right tool. I actually own a flywheel puller, and this will thread, hopefully, if it's the right size. So I'll screw that. This should thread. Wow, there it goes. No, wait, no. I think it's the wrong size, the bastards. Unless it threads in. Oh, it's left-hand thread. Ha. There we go. Look at that. Reverse threaded. Okay, then we're going to take this and back it up against the crank, where we will then use, we're going to turn the crank in the opposite direction, and we're going to use, I bet you this is it's a 17, isn't it? So where's my ratchet? There it is. Yeah, there you go. So 17 mil. I find that all the larger nuts on the Suzuki are of the 17 millimeter variety. There we go. Yep. Just like that. That wasn't so hard, now was it? I was worked up over nothing. There we go. We'll just leave this in here. We don't need it for anything else. And there we're in. We are in. This is a solid state ignition. It does not have any. Now we're going to crack the. We're ready to crack the case. So I'm going to turn it up this way. Well, ooh, this does not look good. It looks like this coil got a little toasty at one point, and I don't like what I'm seeing. But it does generate power, so we're going to just leave well enough alone. But this got hot. Very hot, and it's not a good thing. So hopefully it's not burnt out, because this is expensive stuff here. These are pricey. Now I'm looking for, yeah, I have to pull this all off, so I'm going to have to scribe a mark, or just put a mark here that indicates, in fact I'm going to use a punch mark that'll indicate the current position this is in. So you can see that someone had changed it from its default position. These do not line up. And I'm going to trust that there's a reason for that. So what I'm going to do is I'm going to make my own mark right here. Let's see. I'm going to try to line this right up here. Looks like it's like a percentage of a degree. And I've got my nice little mark right there that I can use as a guide. shows up. I just put a little punch mark right here. Now if there isn't any other, here, I'll put a mark here. And I'll put one right here. There we go. Can't screw this up. Then we're going to take our T-handle. I'm going to put this engine up against the cart so it's not falling over anymore. We'll put these aside. I got to clean all the case bolts with a wire wheel, so I'll have to, my next trip to where my family lives, I'm going to have to go out there and use my dad's bench grinder. And now, where's my T? These are look like a number 2 JIS, which I have on here. I'm going to use that. Okay, get these nice and loose. Oh, a bit stayed. I am a little concerned about that coil. What I'm going to have to do is I'm going to check it for resistance. Okay, that wants to twist out, so I don't want to mess with that one. I'm going to grab this. This is the best tool I ever bought right here. This is it's a punch, and not a punch, an impact, a very crude impact tool, but it works really well for loosening things up. Generally, and generally effective for things like this. There it goes. Alright. You know, when you're working on motorbikes, there are a lot of tools that you do need to own if it's something you intend to do much of, because standard hand tools that most people have in their households are just not enough. And I'm learning this as I go, as I get through and you know, do things. There's a lot of tools you need to buy, and fortunately, thanks to places like Harbor Freight and Amazon and eBay, you can find a lot of these tools for a very low price. They're not as good as what you'd find in a professional shop, but they do the job. So we need to pull this, and I'm going to check for resistance values using the factory service manual that I found online. And yeah, this thing is burnt, but I mean really burnt. But it might be fine. But it does need to be inspected and checked for, and I'll do that in another video. Okay. At this point, we're ready to basically pull this case apart. It's important to know that you need to take these bolts off in sequence. That is important. You just do the basically. I mean, I can't seem to find a torque guide, but I do know that you pick a point to start. I chose this one here, and then you go directly across, and then across, and then across, across, and vice versa. So here we go. These ones are being a bit stubborn. These are tight. There we go. I'm going to go here. Yep. Alrighty, we're in. Well, we're almost in. Now I want to point something out. This seal right here, if this seal ever goes bad, this is the only external crank seal there is. If this ever fails, the engine will develop a rather nasty and difficult to diagnose vacuum leak, causing it to run lean. That's what's going to happen. You may not have a lot of fluid leaking out, but you will have air leaking in. So let's get this apart. First, we need to crack the seal. I'm going to use a rubber mallet. This is actually sealed with a special crank seal. There is no gasket. Crankcase seal. Yeah, there is no gasket in there. And when you hear that hollow sound, the seal is essentially broken. So, or breaking. You don't want to use a ball peen hammer for this. It sounds almost like it's ready to go. Yeah, it's broken. There we go. Not broken, I mean it's cracked. Well, you know what I mean. You know what I'm talking about. Oh, almost lost my oil pump drive screw. Oh, we'll pull that out. Alright, I got it apart, and my suspicions, and the reason for doing all this, have been correct. I was correct. My suspicions were true. This engine has a problem. It had a major problem. Alright, we're going to jump ahead a little bit in the video. I've already made some changes. I put the kickstand back on so that the engine can make it easier to reassemble. I popped out the axle bearing, and I've removed the smoked bearing from the engine case, and we're going to take a look at that. So this engine clearly ran lean for quite some time. It was neglected, the carburetor wasn't properly maintained, and this is what happens when you neglect your two-stroke engine. This is that bearing that we're talking about. It is completely smoked, it got hot, it's worn, it's junk. Let's listen to it. Alright. Listen to that thing. That's not good. A little bit of a knock. Really not a lot of play. I mean, this bearing could probably be cleaned up and oiled and put back in service in a pinch, but I wouldn't dare do that. Bearing that's been overheated like this, that's been oil starved for God knows how long and rev to the moon and back, probably doesn't have a lot of life left in it. So we're gonna toss that. And what happened was the way this bearing is lubricated and cooled. It actually depends on kind of a cross flow through the engine case. So the bearing sits right in this machined depression right there, and there's an oil port right here that allows oil to flow, oil and fuel mixture to kind of flow through under vacuum. It gets kind of sucked through this port and out into the combustion chamber on the intake stroke, and that port is placed on the back side of the bearing towards the seal. And on the intake stroke, it sucks that oil and fuel mixture through the port, through the bearing, and out this outer face. And that is how the bearing is lubricated and cooled. The conversely, the transmission side bearing, which is behind the crank right here, that bearing is located on the transmission side, where it is lubricated and cooled by the oil in the transmission case. So this bearing here, which only has 3,500 miles on it, is still very young. It didn't see the abuse, so we're not going to replace this bearing. There's absolutely no need to remove the crank to do that bearing at this time. Later on in the engine's life, I would go for it, but I'm not going to even waste my time with that. But this bearing here, which would have otherwise been fine had this engine been properly tuned, unfortunately its life has been cut short. So we will be replacing this bearing. I have one on order. We're also going to replace the seal. It may not be this one, it could be another one. But anyway, we're going to also pop in a new seal inside the crankcase half. Now, like I said earlier in this video, if this seal were ever to fail or develop a leak, it would actually cause the engine to run lean as well. So if there's a lean condition already, it'll just make it worse. But secondly, what it will also do is it will reduce the amount of fuel and oil mixture that is available to flow through that bearing, because it can draw in air through the path of least resistance. It could draw it right in through the stator. Although the stator cover is usually sealed up pretty well, so I don't see how that would be the path of least resistance, but you get the idea. Now, if the bearing seal on the other side were to fail, it would start drawing in oil, and we would know if that seal was bad, because we would see oil deposits on this side of the crankcase. There would be oil and sludge on this side as it was drawing in oil from the transmission side. Does that all make sense? I think so. Moving along, I've also pulled the drive shaft slash axle bearing and seal, and here they are. Now, this bearing is actually good. This is the original drive axle bearing, and it has just enough. There's a little bit of resistance. You want a little bit of a resistance, because that means that the seals are still doing their job and that the bearing isn't excessively worn out. It feels really smooth and really nice. There is no notching, no knocking, nothing. It's a nice tight little bearing. And like all bearings of this type, there is a little bit of a side, like a kind of a rocking. You can grab the inner race and you can actually knock it on its axis a little bit. That seems to be pretty normal, even for new bearings. But this bearing is fine. There is nothing wrong with this bearing. These bearings are not really good for that kind of support. For that, you'd want a roller bearing. A roller bearing versus a ball bearing, like this one and this one, a roller bearing would be better suited for side-to-side movement, like that. So if it's supporting a shaft, there'd be much less kind of a rocking or side-to-side movement with a roller bearing. But a ball bearing, just by the nature of design, you're going to have that, I think. I mean, in my experience, which isn't really that extensive. But okay. So let's talk a little bit about the final drive and the axle seal and bearing. So this is a little cover. This is meant to keep that bearing from falling out because it's actually pressed in from this side. Now, if we look inside here, I've already removed the bearing and the seal. There's a little kind of a telltale weep hole. Now, if you see oil coming out the bottom of this case, there's a little port under there. If you begin to see oil coming out of that hole, it means that this seal is defective. This is your axle seal, and this actually goes in before the bearing. It's an unusual design, no, actually pretty typical design for a small bike like this. So this seal keeps oil away from the bearing, because the bearing that they specify in this engine is a double sealed bearing, meaning it has a seal on both sides, a so-called 5302RS. That's two seals basically. And the way this bearing is lubricated is it's permanently greased and then sealed. The seals prevent grease from coming out and oil and dirt and dust from coming in. These bearings have a fairly limited lifespan. They don't last as long as a single seal or an unsealed bearing like this one. These bearings are designed to have oil flowing through them, whereas these are just permanently greased. So these will usually last longer than these. So what happened here is this rubber seal had failed and allowed oil to come pouring in. And what that can do on a sealed bearing like this, especially as they get old and the seals become less and less effective, is oil can pour into these bearings and it can actually destroy the grease by washing it out. And I don't think that quite happened here. I think this one was caught just in time. But as the bike got older and more miles started to rack up on the drivetrain, over time this bearing would be destroyed, ironically, by oil. And It's important that, especially on a bike this old, that seals like that need to be changed. I really should pull this crank out and replace the intermediate seal, but I don't feel like doing it right now. You know, I really have a lot of time into this thing, and I don't think that's entirely necessary right now. But I'll look into it. As the winter wears on, I might zap this crankshaft out of here and start playing with that, but right now I'm not really planning on it. But I should replace that even if I don't change the bearing, I should change that seal out, as a side note. But I'm not practicing what I preach, and I'm just going to change what I have to and nothing more. But this seal is bad, and because I already have this bearing out, I already have a new one on order, so we'll get this replaced, and we'll have a nice rebuilt, semi-rebuilt drivetrain. Now, I wanted to show you this. This is the Flywheel. You see how there's no rust on it? Well, that's not how it was when I pulled it off. I don't know if I showed it on camera, but there was a lot of rust on these magnets. They were pretty scaly. I took this Flywheel and I dunked it in a container of Evapor rust overnight. It actually took about an entire day. And it took all the rust off my magnets. No sanding, no grinding, no wire wheels, nothing like that. Looks beautiful. It is pitted. I mean, it was pretty badly rusted, but it's going to live another day. In fact, I need to clean up my stator. This should be pretty easy, though. Not a lot of rust here. We're going to test this stator coil in a little bit in this video. We're going to see if this is any good. This did get hot. I was very concerned about that, and we're going to take a look at that in a little bit. What else can I show you guys? On the transmission side, again, everything seems to be pretty good and smooth. Not a lot of wear and tear in here. These chains are good. The guides are good. I'm not going to bother changing anything in there. The clutches are good. Again, if I do take the crank out, I've got to zap this off. This is actually put in with, they actually used thread locker on this. So you want to heat this nut up with a torch, get it nice and hot. It should come off with an impact. I'm going to have to do something about keeping the crank from losing its stuff. I'll figure that out. But if I take it apart, I might not. Don't know. I've already cleaned up all the gasket mating surfaces on both the transmission, the case covers, and the crankcase. Cleaned them with, I use, and I've always used, Scotch-Brite pads. Works really well. Works even better if you have an air gun with a Scotch-Brite pad fitting on it. They come in green, white, and brown. You want to use the green. It's the softer. Actually, it's the medium grade softness. White isn't soft. White is too soft, and brown is too harsh, I think. And you want to use that to kind of clean these surfaces up, make them nice and shiny and smooth. When we go to reseal this engine hopefully in our next video, I'm going to be using this. Now this is when you're looking for case sealant, you actually buy it by the industry number. This is AB1207B. This is the same stuff that is used. Actually, this is Honda Bond, 3 Bond, and it's sold under a couple of other different names. It's the same spec as Suzuki Bond, which no longer seems to be in production. But Aisin, this is just a Japanese transmission company. They use the same stuff. And it's designed, it's a form-in-place gasket for cast casings like this. And it even comes with a handy-dandy tube key, so you can roll it up nice and not waste any of it. This stuff is usually pretty expensive. I found that the Aisin stuff was cheaper than the 3 Bond or the Honda Bond by about a couple bucks. But the same stuff, And we're going to use that to make the form-in-place gasket for the crankcase. And I watched a couple of videos on how that's done, because I've never done this before on a 2-stroke. So a lot of things that YouTube is a good resource for that stuff. Alright, moving on, we're going to test the stator, see if that's even usable anymore. I've already mounted my oil pump. I wanted to I'm trying to get things back together a little bit. where possible. So I got a new gasket on there. Nice. I refurbished this oil pump by replacing the end cap seals with seals that I kind of procured on my own. You can't get those anymore. They don't make them. You got to either replace the entire pump or find a used one. But I replaced those. I know they were leaking, so get that done. All right, moving ahead. Okay, we don't use paper manuals anymore. It's all electronic now. All right, so here's what we've got. I've got the chart that tells me what the proper readings are supposed to be. Let me zoom this in using my trusty Lenovo R61. And where'd it go? Where'd it go? There it is. I don't need the bookmarks. Close that. Okay. So you probably can't see that, but anyway, I'll just tell you what they are. I'm going to set my meter to auto-ranging ohms. Okay. So ground would be the plate itself. Let's put it right there. So ground to white and red should be between 0.4 and 0.8 ohms. So I got 1 point, ooh, not good. Oh, 0.6, 0.8, 0.7, 0.5. Okay, I think we're good. At first, it looked like it was 1 ohm. I'm like, oh, that's not good. Now I'm checking it again. I'm getting 2.8. I'm not getting a good connection. Let's try this. Let's try the actual coil that it's going to. White and red is going to this. The coil that we are suspect is as having a problem. So ground to the wire is 1.0. Now it says 0.6. All right, let's get a good connection, yo. 0.3, 0.5, 0.6. I'm going to call it 0.6. I'm going to give it a pass. Ground to yellow-red. And that is on the same coil. So if this passes, we're okay. The reading is supposed to be 0.1 to 0.3. I got 0.5. Well, if I scratch it a little bit, let's see if I can get it down there. Alright, I got a 0.6, 0.8, 0.9, 7, 0.9, 1.9, 2, 4, oh come on now. Now you're just screwing with me. 0.6, 0.5, 0.6. It's not a very good reading. A little out of range, a little out of spec. 0.3. Oh, we got a 0.3. All depends on the alignment of the moon and the stars. There's not really a lot of oxidation here. It's a little high. I'm just going to call it a little high. Alright, ground to, that would be BR. That would be blue and red. That's this one here. Ground to BR. This one's hooded. Stick the probe down in there. Scratch it a little bit. I'm going to probably try to find another stator. Yeah, I'm gonna see if I can't find a used stator for this thing. This one is supposed to be off. It just says off. Off, off, off. So yeah, it's definitely off. Okay, well, red to blue. Or red and blue. Or red and black. That could be red and black. Let's try that. That's also supposed to be off. Alright, so here we go. Yellow, red to white red should be 0.3 to 0.5. Again, that's the same coil. Yellow red to white red. And what do we get? I'm getting all over the map. There we go, 1.6. It's a little high. 1.3. Getting a high reading. 0.3 to 0.5 ohms. But it's weird when I say that it jumps down. 1.5. I'm getting a consistent 1.5 reading out of this thing. But your finger is also affected too. You know what? That's true. I'm also providing my own amount of resistance. So why don't we try this? Why don't we put the probe in one? Alright, and I'm not going to touch the other one with my fingers. What do I get? Let's use a surface here as a 3.0. Come on. 1.4, 1.1, 0.7, 0.6. We're going to call that a 0.6. Okay. Red to black. No, wait. RB to BR. That's basically this black with a red stripe and the hooded one here. I believe this one is our ignition. I get about 200 ohms, and the range is 180 to 220. So we're good there. Yeah, we're good. So what do we got? Well, it looks like our melted coil is potentially bad, and I believe this is our lighting coil. And I know it works, but I don't trust it. The thing is, you see these windings have definitely melted together at some point. There's a short in this coil. There's got to be a short somewhere. And that doesn't mean the entire thing is shorted. What that could actually mean is that if that 1 or 2 or 3 or 20 wraps of wire are shorted together, and that effectively will raise the resistance. I'm sorry, that'll lower the resistance. So it's very interesting. I don't know. I'm going to look. If I can't find another one, well, too bad. Alright. I took another look, by the way, at our cover, and I can just barely make out the punch. One of the punch marks I made. It was just to the left, slightly retarded side of the main timing mark. So I'm okay. We're good. We're good. In fact, I can still see this timing mark that I made. So that's good. We're going to replace this bearing. We're going to reseal the crankcase in another video. And I got to get some parts ordered. But now I know what I need and what it's going to cost. I'm a little worried about this. This might be bad. But it's not totally shorted, so it might be salvageable, it might not be. Well, we'll see. Until then.